Good day everyone, I hope you are doing great from wherever you are watching this video. This is going to be a quick tutorial on how to use RS2 to perform seepage analysis, in this case for an hydraulic structure concrete dam. So this is our model, the problem we want to solve. It's a layered soil and it's a concrete dam of about 10 meter and it's having an upstream of 4 meter and it's a water of 0.5 meter. What we are now given here is the lateral extent, and in some practical cases you won't have this, but there are some rule of thumb you can apply. In this case we'll be applying 1.5 times the depth of the domain, and usually how it happens is you can do the 1.5 and you can do two times the domain and compare the percentage difference in the seepage flow. So in this case, we'll be doing the 1.5. So 1.5 times 10 is going to give us 15, and 15 here, which is 30, and 10, making 40. And for the height, we have 10. That means we have 1 meter into this place, and we have about 4 here. So we have 14. Plus, you can say the total height of our domain is 15. So let's go to RS2 to simulate this. To perform this in RS2, the first thing we need to go to is the analysis and project settings, and we can check our units. The unit for our permeability, we can change it to centimeter per second to match the unit we have in the problem. And the next thing is to go to the groundwater and change it to steady state FEA, finite element analysis, and click OK. To draw our domain, we need to click on add external boundary. You can type letter T, which is table, and press enter. So you can start from 0, 0. Since the width we for the entire domain we estimated is 40, then we still have 0, we have 14, and the total height too, we said 15. We have 0 again, 15, then 0, 0. Okay, so this is our domain. The next thing is for us to divide it. So we can use add material boundary to divide it. Taking our question again, the layer from the below is 5 meter. So we can just use the coordinate 0, 5, then 40, 5. Right click, done. So for the second one, it's not entirely straight. It's going to come like this, down like this. So we're going to bring out, we're going to use the shape of this concrete dam in dividing the layers. So go to our RS2. So this is going to be 10, sorry, 0, 10. Then we move about 15, 15, 10. Then we come down 15, 9. Then we go plus 10, that's 25, 9. Then we go up, that's 25, 10. Then to the extreme boundary, done. Next thing is we can excavate it for our dam, and we can change this to material 2. So we need to simulate impermeable layer for the concrete dam. To do that, we'll be using a structural interface. So we need to define the structural interface, and an important aspect is to make it impermeable. So we need to uncheck this, then click OK. And we need to check here. There's really nothing to check here. We can just click OK. Okay, so the next thing is to add it. So we're going to add it using support, add structural interface, click OK. Since we have a point delta of about 4 meter, so the total is going to be 14. We can just make our dam to be a bit higher than that. So let's say 14.5. So it's going to be 15, 14.5. We are going to click OK. The next thing is to make the base of the dam impermeable. Structural interface. Okay, and just click from here to here, then click done. And the next thing is to make it impermeable too. So using support again. Okay, since it's going to be 0.5 here, so I can just make it 25, 12, and just click it down. So we have our dam. Before we can add our water in RS2, you need to mesh. So you go to our mesh interface. To mesh setup, I'll be using uniform, and I'll be using like a 5000 discretize mesh. Okay, the next thing is for us to add our groundwater boundary. So we click on the groundwater tab, click bordering condition. Since you have 4 meter here, 4 plus 10 is going to be 14. So it's going to be a total head of 14. Click the boundary, apply. And at this side, we have a tide water of 0.5. 0.5 plus 10 is going to be 10.5. Then we click here, apply, close. The next thing is for us to input our hydraulic properties. So for the down layer is 2e minus 3 and top 2e minus 4. So hydraulic properties, it's already in centimeter per seconds. So we have 2, Then we have 2 here. For the one that is down, let me confirm. We have -3 for the one that is down. And for the topsoil, we have -4. 2 -4. Okay. So before we estimate it, like I said, we need to compare the seepage flow. So for us to be able to estimate seepage flow here in RS2, you need to add your discharge section. So you can add your discharge section and click done. So now we can just perform groundwater analysis only. In this case, we can just make it dam analysis, desktop, save. So it's going to compute. After computing, we can check our results using interpret. So this is showing us the seepage flow. This is the influx into the domain. So for us to select a good domain, we can do 2 times the depth. This current one is 1.5, which is 15 here. If we do 2 times, that will be 20 to the left and to the right. Another thing we can check here is we can check the total head map. We can right click here and go to contour option and click fill with lines to see how the head is dropping. And we can also add our flow line by going to groundwater, add multiple flow lines. Click here, right click, done. So it's going to ask you add main vertex. We can select 10, and this is the default step size. You can change it to what you want. You can just click OK. So you can see in this case, this flow line is cutting through a boundary condition. So we need to delete it. So this is the flow line, and this is the total head across the domain. Another thing you can check is the hydraulic gradient if you are designing against piping. If you want to know the exit gradient at the flow at the downstream here, you can just click here, Seepage, and go to total hydraulic gradient. So to know the total hydraulic gradient at the flow here, you can use your query, add query material. You can just put it there, right click, and you can just make it at 2 points. So you can see that your exit gradient is about 0.49. So you can calculate your critical exit gradient and compare with the value you're having here and know the factor of safety for exit gradient or piping there. The next thing you can also do is you can estimate the seepage force under the dam. To do that, you can just use your query, add query material. You can click here to this place, right click, done. And you can, in this case, you can just make it 6. And what you need to do is going to change this and change it to pop prayer. So with this pop prayer, you can estimate your seepage force. And in this case, it's going to give you like a trapezoidal shape like this, something like this. And if you want to reduce probably the exit gradient, let me go back to the total dolly gradient. What you can do is to go back to your RS2 modeler. The same way I added this structural interface, you can add it as a cutoff wall at any location that you think is going to be best to reduce your exit gradients. I hope this video helps. Thank you for watching. If you have any comments, you can put it in the comment section. Thank you.